All right, mathletes, we're back, and this is the actual lesson. The last one was just the warm-up. Holy cow, that was a long warm-up. But let's get on with this. I want you to have the definition of rhombus and square. A rhombus is a parallelogram with all four sides congruent. So all four sides are of the same length, whereas a square is a parallelogram with all four sides and all four angles congruent. They're all going to be 90 degrees is what it turns out. But go ahead and pause this if you need to. I'm going to get moving on. Ready, set, go. Okay, we're going to explore a little bit of the properties of rhombus and squares. So I want you to see, first of all, it's a rhombus. All these sides are of the same length. And we're going to talk about what happens when we manipulate it a little bit. So first of all, I want to show side lengths. Notice no matter what I do, the side lengths stay the same. We're not changing the side lengths. Now, could I change the side lengths? Yes. If I change the side lengths, though, look at that. They stay the same. So in a rhombus, they're the same, even if I turn it into a square. Now I want to talk about angle measures. Okay? Let's try to get them all the same. Right there. Now we have a square. All the angle measures are the same. Look at that. All the sides are the same. Let's look at the diagonals. It's killing me. Of course it's not. Let's see. We should have LQ or LN, excuse me. LN is 6.3. Is it? Where is it? LQ. Okay, it's saying LQ is 6.3, and then QN is 6.3, because those are the same, and it's saying they're supposed to be the same. Oh, I hate that. Did we have for just a second? There we go. Now it's a perfect square. Now we've got the angle measures. Oh, I had all the angle measures. Now we're at a square. I didn't have a square before. Now I got a square going on. So let's look at this. All the angles are measuring 90 degrees. We needed that. I didn't check that first. Once they're all 90 degrees, guess what? These are all going to be 6.2. For this particular length, if I were to change length, which one changes length? I can change length, right? Oh, I get 90 degree angle measure. There we go. So once I changed length, right, it changed the length of everything. But once our angle measures got to 90, you'll notice that all the diagonals are identical. They're all the same exact measure. So when it's a square, they're the same measure. Let's see what happens when they're not. Oh, so that's me there. That's the way I can increase the size. Oh, no, I am actually changing the angle. Now let's look at the difference between a rhombus. They're not the same, but here's what we do know. The distance from Q to L and Q to N is the same, right? And the distance from Q to P and Q to M is the same. They're just not the same as each other. Clearly, we can see that from the drawing as well. But again, side lengths stay the same. And although these angles are supplementary, the measure of angle LPQ, I want you to see that. LP, is that what it is? No, LQP, excuse me. LQP. So it's this angle right here. Notice that no matter what I do, that's staying 90 degrees. So the diagonals of a rhombus not only bisect each other, but they always bisect each other at exactly 90 degrees, whether it's a square or not. So as long as all these side lengths are the same, it's going to do that. So we kind of just exploring a lot there, but let's move on. A rhombus, again, is a parallelogram with all four sides congruent. All of the properties of a parallelogram hold true for a rhombus, in addition to the following theorem. So this is an addition. This is added beyond all the parallelogram theorems that we have, which work for a rhombus as well. We have theorem 7.15, which you should be putting in your toolkit because you can use it on a test. It's printable off of the last lesson if you're not here, or you can get a copy from me in person. All right, what do we say? It says if a parallelogram is a rhombus, then its diagonals are perpendicular, and that's what we just talked about. So if a parallelogram is a rhombus, then its diagonals will always meet at a perpendicular angle. Okay? Pause it if you need to write this down, but I'm going on to the next one. If a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So not only do they bisect, the angles bisect each other like all parallelograms do, but the angles are bisected, which means angle 5 is congruent to angle 6, angle 7 is congruent to angle 8, angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. And on that toolkit, if you have it, you need to write in these angle numbers and make sure you write this down, because we want to have this accurate. Awesome. Again, pause this if you need to. I'm rolling. Example 1, let's take a look at this. Okay, so we have this rhombus right here. Nice. And it says quadrilateral DEFG is a rhombus, which means we know all the side lengths are the same. So what? We know this right off the bat. They're all the same. Find each value or measure. If the measure of angle DEF is 78 degrees. So let's follow that, DEF. So that's this whole thing. This whole thing is 78 degrees. Then we want to find what's the measure of angle GFR. So GFR. So we want to know this angle measure right here. Well, here's what I know. Here's what I'm going to tell you. If this is 78, then I know that angle DGF is also 78, right? And furthermore, I know that half this angle is half of 78, which is 35 plus 4 more, 39. That makes it 39 degrees. So now here's what I know. If this is 90, this angle is 39 degrees. Add those together, subtract from 180 to get our leftover angle. So 39 plus 90 equals 129. And then subtract that from 180 to get that last angle of the triangle there. And we get, that's what, 51? Perfect. So I now know that angle F is 51 degrees, or GFR is 51 degrees. Perfect. If EF, so EF is 3x minus 2, 3x minus 2. And DG is x plus 10. And what does DG equal? That should be a plus sign. That is a terrible plus sign. And that should be an x plus 10. Okay, well, I know the side lengths are congruent, so I can just come up here and say, all right, 3x minus 2 is equal to x plus 10. So what I'm going to do, I'm going to subtract x over and add 2 over. So when I do that, what do I end up with? I end up with 2x. That's canceled out, equals, let's cancel out, 10 plus 2 is 12. And if that's true, divide both sides by 2 and we get x equals 6. So if x equals 6, and I know that DG is x plus 10, that's going to be 6 plus 10, which is 16. Perfect. Again, pause this. I got to erase some stuff, but pause this if you need to, so I can erase stuff. Okay, if GR brown. If GR is 2x plus 12, so GR. Where's GR? Oh, it's this. That's going to be what? 2x plus 12. 2x. Yeah. I'm going to erase that. So I know this line right here is 2x plus 12. In fact, let me do this. Let's just erase all this extra stuff so we can have it out of our way. Then I can write it on the inside. Okay. Now I know that this line is 2x plus 12. Okay. And I know that RE, this line, is 4x minus 10. Okay. Well, I want to find what GE is. I want to find what the whole GE is. If I want to find out what the whole GE is, I need to first solve for x. I can solve for one of these sides. They're both equal to each other, and so I can just multiply that by 2 and find what the whole thing is. So let's set these equal to each other. I'm going to have 2x plus 12 equals 4x minus 10. Let's subtract 2x over, and subtract 2x, add 10. What do we get? We end up with, that's gone, 22 equals, that's gone, 2x. Divide both sides by 2, and I get that x equals 11. All right, so that's important. So now I'm just going to plug it in. I'm going to plug it into the 4x minus 10. So I'm going to have 4 times 11 minus 10, which is what? 44 minus 10? Or 34. So if each of these is 34, so 34 and 34, then the whole thing is what? 68. Boom. Right there. That's a good problem. Okay? Pause it again if you need to. We're going on. Use the diagonals of a rhombus. The diagonals of a rhombus, KLM, intersect at P. If the measure of angle L, I'm going to zoom into this a little bit. Function, oh no, Control plus. So, if the measure of angle LMN is 63 degrees, we're going to have LMN. LMN. So that whole thing is going to be 63 degrees. Find the measure of angle KLP. So KLP. So I want to find this angle right here. KLP. Okay, this is very similar to another problem we just did. What do I know? I know that this angle is also 63, right? Excuse me. I want to write it out here for a reason. 63 degrees. And I know that half that angle is going to be what? 31.5? 31.5. So then here's what I know. They always bisect each other with a perpendicular angle. So 31.5 plus 90, subtract that from 180 will give me my missing angle. So 31.5 plus 90 is just 121.5. So I'm going to have 180 minus 121.5. So that should be what? 58.5. Awesome. So then we know that angle is now 58.5. I'm going to erase it and check it. Let's do it. You ready? 58.5. 58.5. Oh, numlock. 58.5. Check it. There we go. We got it. Got to reset it, though. You guys know how I am. Really reset it. All right. And we got one more example. Before we're done with today. Okay, so we're going to use the definition. BDCF is a square with BC equals 2x plus 5, FD equals 47, and GD equals x plus 12.25. Okay. Find each measure. Oof, I have to do this. Control minus. There we go. So let's write all this stuff down. BC is 2x plus 5. 2x plus 5. FD is 47. GD is x plus 12.25. Okay, then. Well, let's do this. BC, well, I know BC, that's going to equal FD, which is 47, so 2x plus 5 equals 47. Minus 5 from both sides becomes 42. 2x equals 42, or x equals 21. If x equals 21, I'm going to plug 21 in for that, so 2 times 21 plus 5. Oh my gosh, you guys are going to laugh at me. I solved for x, which I needed to solve for x, but I already know that this is 47. I didn't even have to figure that out. I did need to solve for x, so it's important that x equals 21. Oh my goodness, but I was going to like calculate it. That's hilarious. What's CD? CD is also 47. It says it's a square. They're all the same. What's GD? Now that I needed the 21 for, so I'm going to say, all right, 21 plus 12.25 is 33.25, right? That was funny. 33.25. And what is BD, the whole thing? Well, it's that times 2, so 66.5. Right? I would just take that and multiply it times 2 equals 66.5. Because it's just double that. And there you have it. Awesome. That's it for today. So enjoy, and we'll be back to this tomorrow. You ready for that? Peace out.